All right, so let's review what I'm sure is your favorite part of pre-cal, and that was trig. Remember, trig basically came down to this picture here, and knowing SOHCAHTOA, you can get that SO is opposite over hypotenuse, so that would be y over r. Cosine is adjacent over hypotenuse, so that's x over r, and tangent would be y over x. Now remember, with cosecant, secant, and cotangent, those are called the reciprocal functions. So yes, I could write r over y. I could also say flip the sign, okay, which yes would be r over y. For secant, I'm going to flip cosine. And for cotangent, I can say flip tangent, or x over y, which yes, that is flip tangent. And remember, what it came down to is you had to remember those unit circle values of the special angles. So remember, in the unit circle, when, for example, you're asked about the pi over 6's, what is the sine and cosine? If the unit circle, if r is 1, that's what helps us memorize these values. If r is 1, then when you memorize those ordered pairs, remember that cosine is x and sine is y. So if you visualize, again, a pi over 6, which is 30 degrees, is here, you're saying the x and the y of those things. So I remembered that the x was the longer one, so square root 3 over 2. So the x is square root 3 over 2, and the sine is 1/2. Remember that with radians, I mean with degrees and radians, I will tell you that we are in degrees, never. We are always in radians. Your calculator should always be in radians, because we'll always do things in radians. So you should be able to get those ordered pairs thinking around the circle, like at 0, you're going 1 in the x and 0 in the y, right? 45, those were the easy ones. The pi over 4s were easy because it was the same x and y, square root of 2 over 2, square root of 2 over 2. And then 60, those were the ones by the y-axis, so it's short in the x, long in the y, so I'm going to have 1/2 square root 3 over 2. And then, of course, 90 would be 0 and 1. Now, I could go around the whole unit circle. I'm obviously not going to write all of them down. When I go into other quadrants, I just have to remember positives and negatives. So if I'm in quadrant 2, it should make sense that the x is negative and the y is positive. So cosines will be negative, sines will be positive. Quadrant 3, I'll have negative, negative. And in quadrant 4, I have positive, negative. Remember that tangent is y over x, or in other words, sine over cosine. So once I have those values, I can just divide to get tangent. So I'm going to divide sine over cosine. So 0 over 1 is 0. Make your life simple, guys. Cover up the denominators, because if they're the same, they're going to cancel out anyway. So I have 1 over square root 3. I'm going to be honest, I know last year you were like, oh my gosh, that's bad. We rationalized. And that's true. We absolutely did. I will tell you, in calculus, they do not care if you rationalize. So if you give me 1 over square root 3, I'm going to give you full credit. Yes, you need to know that square root of 3 over 3, that they're the same, because you don't know how they're going to type it in multiple choice. But rationalizing is not a big deal in calculus. If I cover up these denominators, the tangent of the pi over 4s is 1. This one is square root of 3. And of course, 1 over 0, that is undefined. Okay? Again, you have to think about in what quadrants will tangent be positive and negative. If the signs are the same for sine and cosine, when you divide, you're going to get a positive. So in quadrants 1 and 3, you're going to get a positive tangent. In quadrants 2 and 4, you will get a negative tangent. I'm going to do the identities, and I'll go back to that well, I'll do the arc trig here. We also last year did inverse trig functions. Remember that that could be denoted two ways, arc sine or inverse sine, which sine to the -1. That's not 1 over sine, which is confusing. But remember, for arc sine of square root 2 over 2, it's almost like you're going backwards. Instead of me saying, hey guys, what's the sine of pi over 6? I'm saying, give me the arc who has a sine of square root 2 over 2. Now what you have to remember is where you look, because when the question is arc sine, there is one answer only. And you have to make sure that you're looking in the right spot. There's not a whole lot of room to write on here. Okay? I'm starting with arc sine. If you look at arc sine and arc tangent, notice that they go from -pi over 2 to pi over 2, which means in quadrant 1, it's no big deal. So if you're doing a positive one, it should be easy. Give me the arc that has a sine of square root 2 over 2. And again, we're always in radians. You would say that's easy. Pi over 4 has a sine of square root 2 over 2. However, if I say arc sine of negative square root 2 over 2, I think we'd all agree that we'd be down there. However, you can't name it as 7 pi over 4. You have to remember in quadrant 4 to name these negatively. And you will do that for arc sine and arc tangent. So notice if I say arc tangent of negative square root 3 over 3, well, that's the pi over 6's. Okay, who has a tangent of square root 3 over 3 is the pi over 6's. But you're down in quadrant 4, so you have to name it as negative pi over 6. So this is for arc sine and arc tangent. For arc cosine, people don't usually miss the cosines because it's normal. For arc cosine, it's quadrants 1 and 2. You name them like you did on the unit circle, so you're good to go. So if I said arc cosine of negative square root 2 over 2, it's in quadrant 2, so we named it 3 pi over 4. So you'll be doing some of those. Okay. Then you'll have to remember some trig identities. Again, those are ones where you have to remember having sine in the denominator is like having cosecant in the numerator and vice versa. We've kind of already said this one, but yes, I could put 1 over cotangent, which is true, but that's also sine over cosine. This one is 1 over tangent or cosine over sine. And the 3 Pythagorean identities. Sine squared plus cosine squared is 1. 1 plus tangent squared is secant squared. And 1 plus cotangent squared is cosecant squared. Now I'm just writing the main ones, but you know underneath each one of these I could write umpteen others because you have to be able to finagle these around. So if you saw 1 minus sine squared in a problem, you have to know, oh, 1 minus sine squared would just be cosine squared. So I could write 10 more underneath those. What about double angles? Do you remember sine of 2 theta? That's 2 sine theta cosine theta. And cosine of 2 theta was probably your favorite because there were 3 different ones you had to memorize. Cosine squared minus sine squared. That's that one. And I always remember the other ones have 2's and 1's, and so keep the same form. So it's always cosine and sine. I'm going to replace the sine with 1, and I'm going to have 2 cosines, and then go from this one, replace the cosine, and you're going to have 2 sines. So those are your 3 right there. So what you'll be doing on the back side is, of course, you're going to be evaluating. So that's really unit circle questions. Remember that if you have something bigger than 2 pi, remember the idea of coterminal angles. is you're going to add or subtract 2 pi to get it in the unit circle with what you know. That is really ugly. So remember that idea as you're doing those. And remember, if I say what's the cosine of something or the sine of something, I can go around the whole circle. It's in the arc sine that you're looking in those specific quadrants. So work on those. You'll be simplifying. So that's like using your trig identities, using algebra and trig identities to simplify those to a single trig function there. And then finally, you're going to be solving. So just like we've solved before, you're going to have two things that have to multiply to be x. You, of course, set each of those equal to 0 and you solve. On 24, you're going to have to factor yourself. So practice the trig, and we will chat about that tomorrow.